So in that manner, we can say that multi-threading than multi-processing will be making use of a shared memory area. Here, we won't allocate the separate memory areas for each and every word. Okay, if it is a common in the sense, it will be stored in a single memory area so that it will take, threads will take very less time to process. Okay, so here we are making use of this Java threading mostly in the games and animations. And if you come with the advantages of this multi-threading in the sense, it doesn't block the user. So that means multi-threading doesn't block the user because threads are independent and you can perform multiple operations at the same time. Okay, and not only that one, we can perform many operations together, so it will save our time. Okay. So threads are independent, so it does not affect other threads. So if an exception occurs in a single thread, it won't affect with the remaining threads. Okay. So likewise, the process will be happening with this multi-threading. So if you want to know this thread, here see, observe here. So this is the life cycle of a thread. So where we'll be having the 5 phases called. One is with the first state is the new state, and next one is runnable, okay, and next one is running, and then waiting state, and then dead state. Okay, so we can say this these 5 stages or these 5 states plays a very prominent role in this for this thread. Okay, we are saying it is like a life cycle of a thread process. Okay, so it is very important to know this 5 stages of a thread. Okay, coming to this new. So this new is nothing but whenever a new thread is beginning, so it will be in the state of new. So it remains in this state until the program is going to start the thread. Okay, we can call it like a born thread also. Okay, whenever a new thread is created, it will be always in the new state only. So for the thread in the new state, the code has been run it and it has not begun its execution. That means it is just a born thread. So that's why we are calling it like a born thread. Okay, so after finishing, that means after this new state, it will be entering into the state called active state. Okay, so either that active state might be a runnable one or else in a running one. Okay, we are specifying that we are having the 2 stages of active state. That is, one is with the runnable and another one is running. See, in the new stage, we are saying that it is a newly born thread. So when a thread is invoking to a start method, okay, so then it moves from the new state to the active state. It moves to the new state to the active state over here. Okay, so that means the active state contains 2 states within one of which is one is with the runnable and another one is the running. Okay, so runnable. So runnable in the sense a thread that is ready to run and then is moved to the runnable state. Okay, that means after coming across with this what we can say new state has been created, it will be moving into this runnable state. Okay, that means the start method has been already invoked over here. So the thread may be running or may be ready to run at this given point of time. Okay, it may be running or else it may be ready to run at a particular point of time. Then we are saying it as like a runnable state. Okay, if it is with a running in the sense, here when the thread gets the CPU, it moves from the runnable state to the running state. Generally, the most common change in this state of a thread is from runnable to running only, and again back to runnable. Okay, so that means a newly born thread is started and the thread becomes runnable whenever it is starting with a method called start. That means from here itself, the execution of the particular thread will be begin. Okay, after beginning that, whenever it is entering into the particular execution of that task in this is, then it will be in the running state. Okay, after coming across with this running, then it is going to enter into the waiting stage, or else we can call it like a blocked stage also. We can either call it as like a waiting stage or as blocked stage. See, whenever a thread is inactive for a particular span of time, so inactive is not permanent, it is temporary only. So if a particular thread is inactive for a particular point of time in the sense, then either the thread is in the block state or else in the waiting state. Okay, for example, a thread, for example, its name is A, and it may want to print some data from the print. So it is unable to perform any execution over here. So here the A will be in the waiting stage and it is going to perform with the thread A is going to perform the execution over here. Okay, that means it will be in the one of the threads will be in the waiting stage and another thread will be executing in the same way. So the method which we are trying to represent over here, so it will be in the waiting stage. So in this waiting stage, we are also having another method called sleep. That means we can make the thread for sleep for certain point of time. That means we are making the thread to stop its execution for a particular point of time, and then again we are making it to execute. Okay, so next one is dead or terminated. So this is a runnable thread which is going to, whenever a runnable thread which is going entering into this terminated state or else dead state in this is, it completes its task only after the execution. Okay, otherwise, if any one of the stage got disturbed in the sense, again it will get terminated. Okay, so termination will happen in two ways. One is with whenever it reaches the end of execution, it enters into the dead state, or else any interruption is going to get happened in the task performance in the sense. So then again dead state is going to get reached. Okay, so this life cycle of a thread has 5 important stages called new, okay, runnable, running, waiting, and then dead state. So we are saying that runnable and running will come under the active state. Okay, so new is nothing but whenever a new thread has been created, it will be in the new stage. Afterwards, whenever it is going to start up, whenever it is about to start the execution, it will just enter into the runnable. And whenever it is currently doing its execution, then it will be in a running state. Even after that one, whenever this task is for waiting for its execution or else some other thing is going to get happen, then it will be in the waiting stage, and finally it is going to end the execution. It is not mandatory for this waiting stage to perform. Depends on the situation, this stage is going to get occur. Otherwise, after performing this execution, directly it will enter into the end stage, that means termination. Okay, so this is how the life cycle of a thread is going to get performed. Next one is Java thread model. So coming with this Java thread model, we can say this as I told you, the thread is existing in several states. No, so we are having this mainly the main thread which is to be used in this Java thread model. Okay, so why? Because the Java runtime system depends completely on the threads for many things, and also all the classes, libraries are designed with multi-threading in mind. Okay, so here a Java thread is said to be an instantiation of a thread class. And here a thread must be created from a thread base. Okay, so we will be discussing those, what are those thread base and what is the main thread in the remaining slides. Okay, so keep it in mind that a thread contains a thread base and it is going to add some hidden control structures in order to permit the thread to run concurrently with other threads. Why? Because we are discussing with the concept called multi-threading. No? So we are not trying to run our single thread. So we are trying to run our threads with the other okay, So here in Java application runs with two main threads. One is with the main thread and second one is the garbage collection. So what is the main thread in the sense? When see, whenever a program is going to get started, so one thread begins running immediately. Okay, so this is usually called a main method or as main thread of our program. Whenever a Java program starts up, one thread begins running immediately. So this is usually called the main thread of our program. So because it is the one that is executed whenever our program begins. See, the main thread is important for two reasons. One is it is the thread from which other chain threads are going to get spanned, or else so it must be the last thread to finish execution because it is going to perform various shutdown actions. So that is why we are saying that main thread is going to play a very prominent role. So we are saying that this is the thread which is going to begin the running immediately. Next one is garbage collection. So we are saying that garbage collection thread is going to deallocate the unused pointer memory. See, we will be storing some values in the memory which we are not at all using. In that cases, the garbage collector is going to deallocate that one. Okay, so that is the main, we can say that the Java is going to run at least two threads in the threading language. Okay, one is with the main method and second one is the garbage collection thread. See, coming with this Java main thread, just now I told you this is the main thread. Okay, so where the running of our thread will be starting from the main only. Okay, so in Java thread model, the action done are usually this. That means it is going to perform the initialization, so such as creating the shared objects. After creating the shared objects, it is going to create the thread base also. Okay, so it is going to main thread is going to perform the initialization. After performing this initialization, so it has to create the thread bases. Okay, and it is going to start the threads and it is going to terminate the main immediately after some signal comes from the thread to terminate. Okay, so as I already told you that we will be having the 5 stages. So after doing the execution without any obstacles, then it will be entering into the termination state only. So once the thread got terminated in this, obviously we are going to terminate the main also. Okay, so as I told you that this is the thread base. So the thread base we are calling like it is an instantiation of a class. Okay, so which is either implementing the interface or else extending the class. See, if you observe over here, so the thread base is an instantiation of a class which either implements runnable. Here runnable is nothing but an interface. Okay, and it is going to extend thread. Here thread is nothing but a class over here. Okay, so if it is not doing these two, okay, if it is not implementing this runnable interface and it is not implementing or else extending the thread in the sense, then it has to create, it has to define the thread-based class called public void run. Okay, so coming to this runnable interface, this is an interface which should be implemented by any class. So whose instances of this runnable are intended to be executed by a class called thread. So that means our main intention is to, so we are trying to run the instances of this runnable interface by a class called thread. So this is nothing but a thread base. So we are saying that thread base is an instantiation of a class which either implements runnable or else extends the thread. So this is the thread base. Next type of thing we are having is nothing but shared base. So here, so we are saying that the thread thread base will be implementing the runnable interface. Now, here in the so shared base is nothing but we are going to create a single thread over here. That means single base over here. See, if you observe, thread base is equal to new thread base. That means I'm going to create a single base over here. After creating this one, if I want to make use of this thread base for some other threads in the sense, we can't use. That means it is not a representation which we can use for more number of threads. Why? Because it is a single thread. Okay. So thread A is equal to new thread base A. Okay. Here A is the name of the thread. Okay. And next thread B is equal to new thread base comma B. Here B is nothing but the thread B. That means for each and every individual threads, we are going to create a new object and we are trying to call that thread over here. Okay, so this is nothing but the two separate bases. Okay, so this is nothing but two separate bases. We are not intended to make use of a single base for two independent threads. We have created two threads called A and B. For these two threads, we are not making use of a single thread base. We are making use of different bases. See here, A for A thread and B for B thread. Okay. And for example, if you assume we are having a three classes, okay, then how we will be making use of this thread base in the sense, see, one is with the shared and second one is the thread A extends thread and thread B extends thread. Okay, here the main function is going to create a single object whose the data members will be shared among these threads. We are going to make use of a single object and it will be shared among these two threads. Okay, see, here I'm going to create one object called yes. Shared S is equal to new shared. Okay, here threads will be created as follows. Thread A is equal to new thread A of S and thread B is equal to new thread B of S. Okay, so that means I'm just trying to create only one object and that object will be used by these two different threads. Okay, that means the execution will get started. Okay. See, that is what I have mentioned over here. See, threads A and B are created. Okay, in this way have distinct thread bases. Okay, that means for example, if we are having two threads in the sense A and B, either we can create a single base for that both the threads or else we can able to share a single object for both the threads. We are having the multiple options over here. Either we can use the single thread base or else we can make use of or else we can create a object for that shared one, and so those two threads can make use of the single object over here. Okay, so here if you see, just we are trying to create an object with this object x is equal to new object. So by making use of this some synchronized keywords, we are coming across with the concept called mutual exclusion. Okay, here each and every object which is nothing but an instantiation of a class in Java, so it will be having some usage of that object in that particular threads. So this may be a disposable of a Boolean locked variables or else a queue for blocked threads. Okay, so mainly if you observe this previous slides, our main intention is to specify that. So the thread base is nothing but an instantiation of a class. So where it has to implement the interface or else it has to extend the class over here. If it is not doing in the sense, then it is going to create a thread based class called public void run. Okay, so this is how we can say that if it is making use of a shared base. If it is not making use of a shared base in the sense, then we can create like a base, okay? And then, so thread A will be created with the object called A and thread B will be created with the object called B, so that we can run the individual thread bases over here. That means two separate bases here. Okay, so and if we want any mutual sharing of that object for both the threads instance, this is how we are going to create. Shared S is equal to new shared, and this object S will be used for both the threads called thread A and thread B. Okay, so this is with the multi-threading and threads concept. So thread is nothing but a lightweight sub-process. So where we can say like a smallest unit of processing. So it can able to perform 5 different stages called new state, runnable state, running state, waiting state, and then dead state. So whenever the thread is going to get started, so it will be in the new state. Afterwards, even if it starts its execution in the sense, it will be in the runnable state. If it is during the execution in the sense, it will be in the running state, and after performing this one, it will reach as the termination. Otherwise, if it wants to wait for execution in the sense, it will be reaching with the waiting stage. If we are trying to perform these threads, multiple threads execution at a time simultaneously in the sense, then we are saying the concept like multi-threading. Okay,